Have you ever been to a very fancy restaurant? Well, maybe not with a PhD wage. As you know, in a very fancy restaurant, everything is neat and clean and well organized. Food, wine, atmosphere. But how does this work? Have you ever taken a look in the kitchen? There is hell going on in there to make your plate arrive on the right table at the right time. A lot of work must be done to keep things well organized. In a similar way, a lot of work must be done to form a human body starting from a single cell, the embryo. This cell has to undergo thousands of billions of cell replication, cell multiplication, and at each of these cell replication, a fundamental process must occur. The DNA must be divided into two daughter cells. For this important process, the cell cannot be just disorganized and messy, but everything must be in the right place. Microscopic motors take care of this. They're like waiters who in a restaurant reorganize everything after a crazy night. They move things around and they prepare the cell for the division of its DNA. The DNA is nicely put in the center, and two guys, the centrosomes, are put at each side. The centrosomes grow some rods with which they grab the DNA, they pull it from the center of the cell, and in this way they divide it equally. If something doesn't arrive in the right place at the right time, if, for example, a centrosome arrives late, well, then the chances are higher that the DNA will not be divided properly. What's the problem? Well, if DNA is not divided properly, in the best case, the cell will just die. In the worst case, the cell will survive as a mutated cell, potentially leading to cancer. As you have seen in this story, there is a lot of physics, mechanics, motors, movements. That's why I, a physicist, am studying this process. In my everyday life, I'm like a new manager who arrives in a restaurant and doesn't really know what's the organization. Then, to understand what's going on, I use a very peculiar strategy. Every day, I fire some waiters, and then I look in the night at what goes wrong. In this way, I can know who does what, and potentially I can spot some lazy guys. In a similar way, in the cell, I remove motors, I look at how the cell is perturbed, and I understand what is the underlying organization. In this way, we're understanding not only how cell division works, but also what happens when it breaks and doesn't work anymore, so that in the future, we will be able to intervene to counteract errors in cell division and potentially, ultimately, fight disease. Thank you.